Hi everyone, welcome to Stats Rescue 911. My name is Lynn, and in this tutorial I'm going to show you how to run a two-way independent ANOVA. Before we get started, there are a list of things that you really should be familiar with before you attempt this, and that is, starting with the top here, the difference between a between and within subjects factor, how to enter factors into SPSS, another name for factor is an independent variable, how to enter dependent variables into SPSS, main effects versus interaction effects, marginal means versus cell means, post-hoc tests, why error bars, and confidence intervals. If you're not familiar with these topics, then I urge you to check out one of my other videos, little mini tutorials, and eventually I'll have them for each of these different areas. All right, well, let's assume that you know a little bit about this, and we'll proceed now with the two-way independent ANOVA. Let's start with a short description of the data set. This is some data that my students collected many years ago, and what they did is they asked men and women about their fears at night and during the day, and they also asked them whether they loved horror movies, liked horror movies, or hate horror movies. And so in this particular example, then we have two independent variables, two factors. We have the sex factor, men, women, and it's between subjects because the people who are in the male group, this men group, are different from the people who are in the women group, the female group. So that's between subjects. The second factor is the horror movie factor, and we have three levels: love, like, and hate horror movies. And participants either said that they loved them, or they liked them, or they hated them. So that means that in each level here, these people, this row is different from these people. So these are different people from these people. So that makes this between subjects. All right, so to proceed with analysis, we need to bring up the SPSS file, and here it is. So we are going to be looking at these fear scores. These are simply the sum of their self-reported day fear and night fear. So each person's day fear and night fear combined gave them their fear score. And we're going to look and see if sex and attitude towards horror movies has any effect on the self-reported fear score. And these were fears that they said they had during the day and during the night. So to start the ANOVA, you're going to go to Analyze, and then you're going to go down to where it says General Linear Model and over to Univariate. Now, I've already moved my variables over, but I'm just going to hit Reset. I want to start right from the very, very beginning, so that way you can follow along. So we're going to move our two independent variables over to where it says fixed factors. It's very rare that you'll see a random factor in the behavioral sciences. Almost all of them are fixed. So we're going to move sex over here, and then we need to find the horror variable. Move that over. Our dependent variable is fear, so we move this over here, and now we've got this set up. All right, now looking at the tabs here on the right, the first one you might want to select is plots. I like to see a graph of my data, helps me to get a quick snapshot of what's going on. So I am going to move sex, well, let's start with horror. I'm going to move horror over to the horizontal axis, the x-axis. And that's because horror has 3 levels, sex has 2. And if I put horror down here, then I'm going to have 2 lines to represent sex, or 2 different colored bars. If I were to switch that and put sex here, that means that I would have 3 lines on the graph, or 3 sets of bars, and I find that a little more difficult to interpret. So the rule of thumb I use is if you have a factor and that factor has more levels than the other one, move that factor over to the x-axis. So that means we're going to put sex as the separate lines, Now we're going to hit add, and I'm going to change that to a bar chart, and I'm going to include error bars on the for each bar to represent the mean, and I'm going to choose the 95% confidence interval. This is where I said it's helpful to know what a lot of these things mean, like what is an error bar and what is the 95% confidence interval, but that's another tutorial. All right, so let's click continue. So we've set up our graph. We are going to get ready and run post hoc tests. We might not need them. Post hoc tests are only done if a main effect is significant and that main effect has 3 or more levels. So we would not move sex over here to the post hoc box because sex only has 2 levels. And so if we do find a significant difference, we'll know where the difference is. But horror has 3 levels. So that leaves many possibilities as far as which means are different from which, love, like, and hate. So we've had to move horror over here. And again, we're not going to look at this unless the main effect is significant. But just in case it is, we need to set this up. We're going to select, as post hoc tests, we'll select LSD, Chaffee, and Tukey, some of the more common ones, and then hit continue. All right, I don't like using EM means, that's estimated marginal means, and that's because they will not be accurate unless your cell sizes are all the same number of scores in every cell. It's not going to be the case, and so I skip that. I'm going to go down to options, and I'm going to select descriptive statistics here, which will be accurate, estimates of effect size, and homogeneity tests. Again, those are the ones that you're most likely going to use. I hit continue, and then finally hit OK. All right, so here are the results. You can see the first box here just tells you what your between subjects factors were. And I actually like looking at this box because it confirms that I entered everything in correctly. So I've got sex, male and female, men and women, horror, love, like, and hate. And I can see my total sample size in each of these groups. These are descriptive statistics, of course. So here we see the cell mean. So men who love horror movies, here was their fair score. Standard deviation and sample size, so it's a relatively small group. We've got men who like horror movies, again the mean, standard deviation, sample size. Let me point out though what this total refers to. So men total, that would be the total mean for the men regardless of whether they love, like, and hate horror movies. So this is a marginal mean. It's the mean for all the men in the study. We're not breaking it down according to love, like, or hate. Similarly for women, the total, so the marginal mean for women would be 8.02. And again, that's ignoring the classifications love, like, and hate. It's a marginal mean. And then finally, if we look down here where it says total love, like, hate, this would be the marginal mean for love. So regardless of whether you were male or female, these are all the people who said that they loved horror movies. The mean for like and the mean for hate. Okay. The next box here is Levine's test for homogeneity of variance. What we're going to look at here is the statistic where it says based on mean. And this is the F value for Levine, 2.73. I'm rounding. This is not particularly exciting. What we really want to look at is over here where it says sig. That tells us whether Levine's test is significant or not. The sig value is 0.029, which is less than 0.05. So we do have a significant test, a Levine's test. Unfortunately, it means we have violated homogeneity of variance assumption. So it's not what we were hoping to see. It would have been ideal to have this greater than 0.05 because that would mean no violation, but that's okay. we have a violation, what we're going to do is, or what we can do, I should say, option is in the ANOVA that we're going to look at next, instead of saying something is significant at p less than 0.05, we may want to adopt a slightly more conservative alpha and say that we will only reject HO and say something is significant if, for example, p is less than 0.01 or 0.03. All right, so we just make it a little more difficult for us to reject HO in the ANOVA. All right, so this was the test for homogeneity of variance, the assumption. A little disappointed that it was significant, but if we look at our ANOVA results, it seems that we need not worry, because remember I said we're only going to say something is significant if p is less than 0.01. Well, if we look at our factors here, we've got sex, horror, and the interaction effect. If we scoot over to the sig values, these are all less than 0.01. So even with a violation, the ANOVA is robust enough. We probably are getting accurate information here. All right, so let's look first at the sex variable. This would be the main effect of sex. We go over here, we see the degrees of freedom associated with this effect are 1. And then down here for the error term, it's 52. I wish this double click would go away. It's kind of always in my way. So let me show you again. So here's degrees of freedom 1. And for the error term, 52. Now let's read over here. The F value is 12.96. And there's the sig value 0.001. And the effect size, partial eta squared. So sex is accounting for roughly 19.9% of the variability of the fear scores. Okay, so almost 20% of the variability accounted for by sex. Let's look at the main effect of horror. The degrees of freedom are 2 and 52, and the F value is a whopping 31.24. The sig value, 0.000. Now that's not the same thing as saying 0. It's just saying to the third decimal place it is 0. And if we look at the partial eta squared, we see that roughly 54.6% of the variability in the fear scores is accounted for or explained by whether they love, like, or hate horror movies. Now, before you get really excited with this finding, I do have a confession. This was the one variable where I had to tweak the data to get some reasonable results. So this is not actually real data here. This is fictitious, the horror factor. All right. Okay. Finally, we'll look at the interaction effect. And between sex and horror, the degrees of freedom are 2 and 52. The F value is 6.22, and again we have a significant effect because the P value is 0.004. P value and sig value mean the same thing. The effect size is 0.193, so roughly 19.3% of the variability in the fear scores is accounted for through the interaction of sex and horror. All right. So the next step, technically, because we have a significant interaction effect, we would need to run tests of simple main effects, and I'm going to show you that in another video. And when you have a significant interaction effect like we have here, basically what you do is even if your main effects are significant, you would not go on to interpret those. You would say in your report that both main effects were significant, but for example, this horror factor, even though we ran post-hoc tests and we've got a significant result, we're not going to bother looking at those post-hoc tests because, again, the interaction is significant and that's what we need to focus on. All right. Now, If the interaction effect was not significant, then by all means, you're going to want to go on and interpret your main effects. You're going to want to look at the post-hoc tests. Let's pretend, just so that you can see how it's done, let's pretend this interaction was not significant. I'm going to show you how to interpret the post-hoc tests. All right? And then you can click on the video that shows you how to run the test of simple main effects. So here are the post-hoc tests for our main effect of horror. And we have the two key tests, Chaffee and LSDT. Let me just show you how to interpret Tukey, because the Chaffee and LSDT are done exactly the same way. So first of all, we need to start up here with love and like. This is going to tell us whether these two means are significantly different from each other. So if we go here, love and like, we read over till we get to the sig value. And yes, we can see that there is a significant difference between love and like, right, in terms of their FAIR scores. Now, what about love and hate? Is there a significant difference? And the answer is no, because the sig value is greater than 0.05, right? So we've done love versus like, we've done love versus hate. Now we need to do like versus hate, so that's this combination here. So if you read over, you can see that it is significant. So there is a difference between like and hate. So the only two that weren't different are love and hate. And I did ask for a graph. You could ignore this homogeneous subsets. Now, here we're not looking at the difference between love, like, and hate. This is a plot of the cell means, all right? And we are going to need to run, again, test of simple main effects because the interaction was significant. But we can just eyeball it, and we can see that men and women are not performing the same, or reporting the same fears, I should say. They're not reporting the same fears. It really does depend on whether they said they love horror movies, like horror movies, or hate horror movies. All right. So we'll turn our attention there in just a second. I just want to point out that because up here we were looking at the marginal means, comparing love versus like, etc., that was ignoring the sex factor, whether they were male or female. So once you know which mean is different from which, the last step to look at the post-hocs would be to go right back up to where you had the descriptive statistics, and we will then know which means are different from which by looking at the means reported here. So for example, we can see that people who love horror movies reported significantly more fear than those who like them. Same thing, those people who reported hating horror movies reported more fear than those who like them. So it appears that if you like horror movies, you have the least amount of fear. All right? So that's how you would run a two-way independent ANOVA. Again, I've shown you how to look at the main effect of each factor and the interaction effect, and how to check your assumptions, Levine's test. So now we're going to stop this video, and I encourage you to watch the video on interpreting tests of simple main effects, running them and interpreting them.